This is a total production.
Hello surveyors, here's our second practice video for chapter 3, and so now we're looking at something very similar to what we did in the previous practice video, but now we're not going to be looking at them where they give us the proton number, the atomic number, and the mass number. Now we're just given an atom or an ion, and from there we have to determine how many protons and how many electrons, but also how many valence electrons those have. So for this in particular practice, it is absolutely vital that we use our periodic table. Alright, so what do we need to do? So our first three options here are sodium. Okay, so Na, sodium. So we need to go to our periodic table. Sodium here. Alright, there it is. Now, with sodium, you notice it has that 11 up top. That's how many protons it has. Alright, now here's the thing. All of these are sodium. Na, Na, Na. So that means they all have to be the sodium ion originally. And when it gets a charge, it does not lose protons. If it lost protons, then it would no longer be sodium. So the number of protons for these three are exactly the same. 11, 11, and 11. Now where they're going to differ is going to be the number of electrons they possess. That's the only thing atoms can lose and still retain their original identity of being, in this case, sodium. Alright, so what happens? When it's neutral, we have an equal number of electrons and protons. So here it is 11. Now remember, electrons are typically denoted as E minus, right? So if sodium gets a positive charge, it either gained or lost an electron. Well, what would make sodium more positive? Losing an electron. So that means here it now has 10 electrons. Okay. Now also from here we see Na minus. So compare it to sodium, and now it got a negative charge. So it had 11 electrons. So how's it going to get a -1 charge? It had to gain an additional electron. So this has 12. Okay. Now from here, it wants us to look at the number of valence electrons. What are valence electrons? Those are our outer shell electrons. So let's look at sodium here, right? If we're looking at these 1, 2, 3, 4, 5, 6, 7, 8 columns. Oh, you can't see everything. So if we're looking at columns 1, 2, 3, 4, 5, 6, 7, 8. If we look at those, it's fairly simple, right? If they're neutral, all of these have 1. If they're neutral, everything in this column has 2 valence electrons. If it's over here, it's got 3 valence, 4 valence, 5 valence, 6 valence, 7 valence, and 8 valence, right? So from there, that means we're looking at the possibility of something called an octet rule. Like for these guys, we're looking at a maximum of 8 electrons. All right. Okay, so sodium originally, when it started out, right, it was in this column and it's neutral, right? So it had just 1 valence electron. Now, here it went to Na plus, all right? So what does that mean? That means when it lost the electron, it backs up to 10 here. So now it has this many electrons. It has 10. And so, but its valence shell is now the second shell, right? Because this is the first shell, this would be the second shell, and this would be the third. All right, it gets a little weird down here. Like technically, this is the fourth for these guys, but it's the third for these guys. Yeah, that's something for later. All right, but so it was in its outer shell was the third shell when it was neutral. Then when it lost an electron, it went here to the second shell. So how many valence electrons does it have now? It has 8. All right, that's why sodium loves to lose an electron, because it gets a full valence shell at 8, right, when it loses it, because it turns into the noble gas, more or less, for its electron configuration. All right, here we have sodium minus, so that means it gained an electron. So it was here at 1, so then it jumps over here to having 12 electrons, so it's in the second column. So it has 2 valence electrons. All right, next up, we have fluoride. All right, so with fluoride here, let's find it. Fluoride's right here. So here we have a neutral fluoride, a +2 neutral fluorine, a +2 fluoride, and a -1 fluoride. So let's start with just regular old neutral fluorine. What's on the periodic table here? So it starts with, it's neutral, so it starts with 9 electrons. Okay, it has 9 protons, it's neutral, so it has to have 9. Now, to get all of these have 9 protons. My bad, I'm jumping the gun. All of these had 9 electrons. Now, if we look over here, for this to be neutral, it had 9 electrons as well. So 9 protons, 9 electrons. Now, we look at F-. That means it had to have gained 1 additional, right? To become F- here, it had to gain 1 additional and get 10 electrons. Now, for it to become positive, that means it had to lose electrons. So now that that's a +2, that means it lost 2 electrons. So here we would do 9 minus 2, or 7. Okay, now, with that, what are our valence electrons? Let's look at neutral here. Fluorine is right here in the 7th column. So it started at neutral with 7 valence electrons. And then when it gained an electron here at 10, right, it got an additional one, so it was 8, right? So it has the same number of electrons as just a neutral neon. Now, let's look at the guy that lost 2, right? So it was at 7, and then it lost 2, so that means you jump 1, 2, jump back 2. So it's got 5 valence electrons now, right? So 5. Okay. All right, next up, we've got some nitrogens we're going to compare. All right, so here we have a neutral, a +1, and a -3. So now we look at nitrogen here. It's got 7 protons to begin with. And remember, just because it becomes an ion, it can't lose the protons. These are still nitrogens, so it's 7 and it's 7. Now, the neutral one, right, if it has 7 protons, to be neutral, it has to have 7 electrons. Okay. But if it has a +1 charge, that means it lost 1 of its electrons. So it's 7 minus 1, or 6. Now for this guy, he's -3. So that means he gained 3 electrons. So 7 plus 3 equals 10. Okay. Now remember, all of these are the total number of protons and electrons. Now this next column is all about the valence shell, the outermost shell. So let's look at nitrogen. Its outermost shell is here to begin with. So that means we just count over 1, 2, 3, 4, 5. All right, so nitrogen, when it's neutral, had 5 valence electrons. Okay. Now, when it lost an electron here with a +1, right, that means that it jumped back 1 to where now it only has 4 valence electrons, like carbon does, like neutral carbon does. Okay. Now let's go back to the original 5. Okay. Now if we look at 3-, it gained 3. 1, 2, 3. So that means it has a valence shell similar to that of neon, where it has 8 valence electrons. Okay. All right. Next up, we've got 3 sulfurs we're going to compare. All right. So for these 3 sulfurs, let me move up a little bit. All right. So for these 3 sulfurs, we start looking here. Right. I'm going to start with neutral. So how many protons does it start with? 16. And since it's neutral, that means it also has 16 electrons. Okay. Now, all of these 2 are sulfurs as well, so they have the same number of protons as neutral sulfur. Right? The negative and the positive just means we change the number of total electrons now. So here you went to -2, meaning it gained 2 electrons. So it goes 16 plus 2, or 18. Okay. Here you go from neutral to +2, so that means it lost 2 electrons. So you're looking at 16 minus 2, which is 14. Okay. All right, now let's look at the valence shell. We can see sulfur here is in the 3rd row, right? And so it starts with 1. So when it's neutral, it has 1, 2, 3, 4, 5, 6. It has 6 valence electrons. All right. Now, when it gains 2 electrons, like it did here, right? That means it goes +1 plus the second one. You're here at argon. So now you have 8 valence electrons for that. All right. Now, vice versa, when you have the +2, you would start at sulfur, and then you would say, all right, well, minus the first one, minus the second one. Now you have the same number of valence electrons as silicon, which would be 4. Okay. All right, next up, we got neon, just neon by itself. Now, in this one, I didn't show a plus or a minus because neon is a noble gas, and so it really just prefers to not have a charge. It prefers to be neutral, right? Being noble. When something's noble, you can think of it as lazy, right? A lot of times we think of the nobles as lazy people. That's not necessarily true, but some of them are. So I think the loudest ones are. Anyway, so with here, neon, right, you are at 10 protons, and it's neutral, so it's going to have 10 electrons. Now for the valence, you have to look at this outer shell, which is going to be this row, just this bottom row that it's in. So it's got 1, 2, 3, 4, 5, 6, 7, 8. All right. And so since it already has a full valence shell, that's why it doesn't prefer to have a charge, and that's why I didn't show neon with charges. Okay. All right. Anyway, so hopefully this helps you in kind of seeing the total for atoms, for neutral atoms, for their ionic counterparts. You know, what happens to their, does something happen to the protons? No. But does something happen to their electrons? Yes. Okay, does that change their valence shell? Yes, and that's only their outer shell that we really worry about when we say the word valence. All right, anyway, so from there, hopefully y'all are prepped and ready to go for the quiz. Adios.